Here's a group of problems that are all dealing with calculator active questions. Calculator active is the terminology that the AP writers use to talk about a question where not only is the calculator a helpful tool, but it's actually a necessity to solve problems. So I'm going to go through and take you through 3 examples. When you take your Chapter 3 test, it is divided into a non-calculator and a calculator section. And historically, what most students tell me when they finish is they actually found the calculator section to be harder, even though they had a calculator to use. Because they had that calculator to use, the questions tend to be written in a way that maybe is a little more complicated, or it requires them to figure out not only how to enter something in their calculator, but how to interpret what they put in their calculator. So here's the first question, very similar to what you're going to see on your test, where it gives you a derivative function. We do not know what the original function is, nor will we need that. And it wants to know how many extrema, relative extrema, is it going to have on the given interval for the original function. And in addition to that, I'm going to go further and talk about where would the extrema be located, and is it going to be a minimum or maximum, or is there one of each. So the way you want to start these problems is you want to get a look on your calculator. You want to see what this graph looks like, because we don't know what the original function is. We can only look at the derivative. So when you go to your calculator and you go to y equals, first of all, make sure that you have nothing plotted in y equals, anything that you've done before. Kind of get your screen clear. Next, you want to make sure you enter your function. So you're going to have the cosine of x. And what you'll notice from the way the problem's written, a lot of times students will say, how do I know what the angle is? The angle of your trig function is whatever is immediately following it. If it's more than one piece, they have to use parentheses. There is no parentheses here, so the angle is just x. That is a very important piece when it comes to entering. And then minus x plus 1. And I'm not just going to hit graph because I only care about this function on a particular interval, so I'm going to make sure my calculator only looks at that interval. So if you go to your window button, adjust your window so that you're only looking from 0 to 5. In addition to that, I'm going to change my y's as well. When you think about extrema by looking at a derivative, you're really looking at to see where does the derivative equal 0. So you're looking for the intercepts, the x-intercepts of the graph. So I don't really care about much other than right around the x-axis. So I'm going to change my y values to -2 to 2. You could even do -1 to 1. I don't want my screen to be too big because then it's going to be a little harder to interpret. When you hit graph, this is what you get. Another side thing, please make sure you're in radian mode. If you switch your calculator out for maybe your physics class, we are always in radian mode. So this is what we should see. My window only goes from 0 to 5, so I'm not distracted by anything outside of my interval. And first thing I want to look at is what extremas do I have? And if you look, what you're looking for is where does it cross the axis. So I'm going to draw a little picture right here so I can kind of write on it that I have this graph that looks something like this. Right here where it crosses the axis, that is going to be a place where you have an extrema because the derivative has switched from being above to being below. So when your derivative goes from a positive value to a derivative that has a negative value, that's telling me that my original function must be going from increasing to decreasing. So yes, it does have an extrema. It only has one. And the type of extrema, if it's going from increasing to decreasing, would be a maximum. So to answer the first question, how many extrema it would have, that would be 1. To answer where would they be located, now you have to know how to use your calculator. When you look at this picture again, if I want to know exactly where that is, well, I could approximate it. It's obviously a little between 1 and 2, closer than 1. But I want to make sure I can get an exact answer, especially if this is multiple choice and you have a couple answers that could be close. So you're going to go to your calculate menu, which is second and trace, and you're going to find the 0. And you're going to need to find your left bound. It might have to, I need to use my left arrow to get it to come back up. Here is my left bound. You could also just type in a number that's to the left of the 0, like 1. Hit enter, and then I'm going to go on the other side of the 0. Hit enter, and then you'll have to enter one more time. Now I know exactly where the maximum was. This is not something I could do without a calculator. It's not something that I could solve in any way by hand because of the trig in there. So now I have a lot of specifics. I can tell you exactly where the extrema is. I can tell you the type of extrema. So going through decimal places, I'd write 1.283. And it is a maximum. If I was asked to justify this, I would say, well, I know it's maximum because my derivative changed signs there. It went from a positive derivative to a negative derivative, and that means that we have a maximum at that location. You could also draw a little picture to kind of help your explanation, that it goes from increasing to decreasing, kind of like what we did in class where we drew like an arch like that. So that's the first calculator active one. Obviously could not do any of that without a calculator. Second one is very similar, really getting comfortable with the same idea. I took this one directly from a practice AP test. The only difference here is now they're talking about the second derivative. So I want to know about the second derivative and how that helps me talk about the original function. I want to know how many points of inflection does this function have on the interval -10 to 10. And you'll notice there is nothing more. I don't need to know where. This question was a multiple choice question on a previous AP practice test. So I'm going to go back to my calculator. I'm going to go back to y equals, and instead of this function, I'm going to put in the new one, x sine x. Notice that the only part of the angle is x, and then -2. I'm going to change my window. I want to go between -10 and 10. Whatever interval they tell you, that's your interval that your window should only focus on, or else you might find answers that are not supposed to be counted. Hit graph. The question wanted to know how many points of inflection would the original function have. Points of inflection on the second derivative are where the second derivative is 0. So again, it's places where it crosses the x-axis. It does have to go from below to above or above to below. And you can count. Again, you're counting on this. If I go to write on my picture, it's going to disappear. So I'm just going to talk about it. You're going to count all the places where this graph crosses over the x-axis. You can see that there are 2 on the left side of the graph. There are 2 on the right side of the graph. So I would say that this one has 4 points of inflection. If it has to justify, I can say that at all of those points, my second derivative changed signs. It went from either positive to negative or negative to positive. That was a particular problem on that AP test. It was multiple choice, and so your answers were something like A was 3 times, B was 4 times, C was 5 times, just going through how many times does it have a point of inflection. The last problem on here, the calculator is going to be more helpful with the computation as opposed to the necessity it was with the picture in the last couple. This is an example of a problem that comes from the very last section in the chapter. Section 3.9 dealt with differentials and differential form, and it wants to approximate the change in volume of a sphere when the radius is increased from 10 to 10.02. We also call this error propagation, so another wording could be to approximate the error in volume whenever the radius is measured from 10 and then the next time 10.02. This one, again, also came from a practice AP test, so I tried to use the same wording that they did in their problem. I am giving you the equation for volume of a sphere. I derive it in differential form. It will look like this. dV, which stands for the change in volume, or the error in volume. Do a power rule on the other side. You get 4 pi r squared dr. The dr, and sometimes in class we use the delta r, stands for the change in radius, or the error in the radius measurement. Plug in what you know. You know that my radius was initially measured to be 10, and then the change in my new measurement is 0.02. And I'm looking for how that affected my volume, what the change in the volume was. So I'm going to go to my calculator, and I'm going to type in exactly what's here. So I'm going to type in 4. I'm going to multiply the pi through just because this problem actually wasn't a calculator section when they did that. You could leave your answer in terms of pi, times 10 squared, which is 100, times 0.02. So that's giving me a change in volume of 25.1, I think it was 132 or 133 if you choose to round. Couple ways this could be asked. If that's all it wanted, if it wanted we call that propagated error, that would be done. If you want to compare it to the actual volume, so you can take this and figure out your actual volume, would be 4/3 times pi times 10 cubed. So my actual volume was 4/3 times pi times 1,000. My actual volume was 4,188. This actual problem that was on an AP test, they wanted to know also what the new volume would be with that measurement, so they went through and took the 4,188 and then added it to the 25.132. So there's a lot of different ways this question could be asked. The most common way is for this right here, to show how that change or that error that resulted from that different measurement. Again, we talked about percent error in class, we talked about relative error in class, but truly the most commonly asked question is to just find that propagated error or that change in your new measurement by using differential form.